Honored guests, Sunny Bonani, good evening, and a heartfelt welcome to the professorial inaugural lecture of Professor Feroz Mahomed Swalaha. It is with immense pleasure and a sense of pride that we gather here at the DUT Hotel School this evening to celebrate the remarkable achievements and scholarly endeavors of Professor Swalaha. Before I continue, let me also extend a warm welcome to members of the procession, and in particular to our Vice-Chancellor and Principal, Professor Tandwa Mtembu, to the Deputy Vice-Chancellor, Research, Innovation and Engagement, Professor Nemavola, the Executive Dean in the Faculty of Applied Sciences, Professor Singh, the Deputy Dean in the Faculty of Applied Sciences, Professor Kudanga, members of faculty, colleagues from the academic, administration and support services sectors at DUT, to Professor Swalaha and his cherished family and friends who are with us this evening, to members of the executive, students, staff, alumni, and our distinguished guests who are joining us online on our YouTube channel this evening, those who couldn't be here and watching us remotely. Your presence this evening adds great significance to what will be an auspicious occasion, and we're deeply grateful for your unwavering support. Professor Swalaha's journey to this momentous milestone has been characterized by his unwavering dedication, his profound expertise, and consistent commitment to advancing knowledge and scholarship. And he also epitomizes and lives the values and principles of our DUT and Vision 2030 strategy. His contributions have not only elevated our academic community, but have also inspired countless individuals to pursue knowledge and innovation. When I joined the university in 2011, I had high hopes of writing a paper with one of my esteemed scientist colleagues to prove that mass extinction happens on a geologic timescale. I first approached Professor Singh, and he washed it off and he says, it's nonsense, we practice proper science at this university. Then I approached Professor Swalaha, and to my surprise, he entertained me. But in life, there's nothing for nothing. And in that entertainment, even though he declined my offer to write a Nobel Prize-winning paper to prove that mass extinction happens on a time scale, he called me 3 weeks ago and he says, you know, it's my inaugural lecture. I did help you and entertained you about your whole dinosaur theory thing. So please, will you be the program director at the lecture? So, you know, in life there is nothing for nothing, but it's my privilege and pleasure to be with you. So as we assemble this evening, it's a significant moment, ladies and gentlemen. We reflect on the profound words of Malcolm X, who famously stated, education is the passport to the future, for tomorrow belongs to those who prepare for it today. So with that, as we embark on this enlightening journey through Professor Swalaha's inaugural lecture, filled with insight, wisdom, and inspiration, I'm going to ask the Vice-Chancellor and Principal, Professor Mtembu, to please come to the podium to deliver the official opening remarks for this evening's inaugural lecture. Ladies and gentlemen, Professor Mtembu.
Thank you very much, Program Director, Mr. Alan Khan. Warm greetings to many officials of the university, including the Chancellor, maybe Chair of Council, who couldn't be with us, and they would have loved to be with us to celebrate this very important occasion. The Deputy Vice-Chancellors, Executive Deans, members of Senate, members of the Institutional Forum, members of the Executive Management Committee, professors of all categories, our broader academic staff members, our esteemed and distinguished guests, ladies and gentlemen. Given that Professor Swalaha's inaugural address is being given tonight, I have to make a special acknowledgement of his special guests, his family, seated just behind him, and many friends within DUT and beyond. It's really my singular honor as Vice Chancellor and Principal to welcome you all, and also to congratulate Professor Swalaha on this very important milestone. We are gathered here, in case you've just found yourselves here, we gathered here because recently Professor Swalaha was promoted to full professor in the Faculty of Applied Sciences. And there's more that is going to be said later about his work in that faculty. So, to Professor Swalaha, your family and friends, good evening and welcome. Maybe before I go to a few other comments, I must just explain that sometimes there are questions within our university about the discrimination that some see when, without any vacant position having become available, they just find out that somebody has become a full professor. And then they say, why is this not opportunity available to the rest of the staff? This is discrimination. Well, let me say something about universities broadly that will make those people who make such arguments understand why, hopefully. Universities are very old institutions. They emerged during the medieval period more than 1,200 years ago. As you could see as we came into this venue, pomp and ceremony is part of university life, and it goes back to those periods, because being educated, let alone being a professor, is no mean feat. You know that it's presidents who are usually inaugurated. A professor also gets inaugurated, as we are doing tonight. That's how important, of course, vice chancellors too, but but that's how important ascending to full professorship, that's how important it is, and that's why, just like with presidents, it's embedded in pomp and ceremony. More poignantly, though, the inaugural address is about at least two things. Firstly, it's about getting to know what Professor Swalaha professes about. In this dear country, as you would all know, corruption has even escalated into awards of fake professorships to some people who have absolutely nothing to profess, perhaps some hot air and nothingness on TV and wherever. So that's the first reason why we are here. And secondly, this inaugural address and ceremony is about inducting Professor Swalaha to the coveted and esteemed class of academics that are at the apex of the academic pyramid. And those who sit at this apex of the academic pyramid, and allow me to quote Ronald Barnett. Ronald Barnett is a higher education specialist. He wrote a book in about 1990 about the idea of university education. There's something very profound but also intriguing that he says somewhere in the book. He says, university education is not about learning. So if any student or any lecturer came to the university because they thought it's about disseminating knowledge, it's about learning the knowledge or learning about the knowledge that is disseminating, Ronald Barnett says, no. Yes, university education requires that you would have learned something at some stage. But most importantly, it's about what you have been able to do with what you have learned all of these years in terms of creating something new, something that has never been imagined before on the basis of what you may have learned over the years. That's the essence of a university, as opposed to a school. At a school, we churn out all the knowledge that the young people need to know. They don't have to innovate. They don't have to be necessarily creative about that knowledge. But here, and what we are celebrating tonight, is that at a university, you can't just be happy about accumulating knowledge. You have to be happy about reimagining the knowledge base you have. You've got to be happy about being creative with that knowledge, being innovative with that knowledge, and producing new knowledge. That's how the world has been able to progress to where it is. It's not been about just learning, but it's been about using what has been learned to create something new. So those who wish to find themselves having been promoted must tell me what is it with their knowledge that would match that which a professor produces through being creative, innovative, through imagining the world in ways that might never have been done before. That's why we have this special position that professors have to be recognized on the basis of the work that they have done, not to have a position established for them to become professors, but to become professors in their own rights. That's what a university is about. And in closing, thank you very much, Professor Swalaha and many other professors before and after you for keeping our university the way it should be through your research, through your innovations, your creativity. The world will always be a better place with the kind of work that our professors produce. Thank you very much and welcome you all.
Siyabonga Mbalasi. Thank you so much, Vice-Chancellor, for those inspiring and insightful words. Interesting, Vice-Chancellor, 1088 was the year the University of Bologna opened to become formally established as the first university in the world, would graduate its students with degrees and had professors, people who would profess knowledge. And it was such a valuable thing that when the students graduated, their names and their professors would be plastered onto walls with family emblems. And it's when you walk through those halls and you look at those names of students and their professors that go back over 1,000 years, it's just a remarkable thing. And some of the first subjects they taught, and I know Professor Mtembu is a mathematics specialist, was mathematics, medicine, philosophy, and science. So it really fits in spectacularly tonight with the Faculty of Applied Sciences and Professor Swalaha's role at the university. Speaking of the Faculty of Applied Sciences, Vice-Chancellor, ladies and gentlemen, I'd like to welcome to the podium to present the introduction of our inaugurand this evening, the Executive Dean in the Faculty of Applied Sciences, Professor Suren Singh.
Good evening to the Vice-Chancellor, the Deputy Vice-Chancellor, Executive Deans, all our DET executives, professors, academic staff, faculty members, family and friends of the Swalaha family, and the man of the moment, Professor Feroz Swalaha. I'm very thrilled to kick off 2024, especially on behalf of the faculty, to celebrate the remarkable achievements of Professor Feroz Mahomed Swalaha. His dedication and contributions to the university for almost 30 years has been exemplary. And tonight, we gather to honor his legacy at the special inauguration event. Professor Feroz Mahomed Swalaha was the sixth born on 17th August 1967 in Overport from a large family of two brothers, Imtiaz and Shiraz, and four sisters, Shaida, Rahana, Asghari, and Fozia, who is now late, with Feroz being the only sibling that pursued higher education. His early education was at St. Aidan's Primary and at Overport Secondary. Before I delve into the details of his research and academic pursuits, I would like to take a moment to acknowledge his late father, Mahomed Swalaha Rasool, who was a printer in the printing industry. He was hardworking and a dedicated man who instilled values of perseverance and integrity in Feroz. Though he is no longer with us, his memory and teachings continue to guide Feroz each day. Feroz also remains deeply indebted to his late mother, Zulekha Rasool, who has been his pillar of strength and support. She was a remarkable woman who, despite facing many challenges after his father's passing in 1980, managed to raise 7 children with grace and ingenuity. Her resilience and unwavering love have been his constant source of inspiration. She sadly passed on during COVID. Feroz is also blessed with a loving wife, Anisa, a high school teacher, specializing in matric maths and science, and 2 beautiful daughters who are with us here today. Anisa has been his partner in life for almost 30 years, and her unwavering support has been the bedrock of his success. His eldest daughter, Nafisa, completed her honors in finance, and his second daughter, Nasia, is completing her 4th year in law. So he's outvoted, has no finance, and has legal proceedings awaiting him. So, sorry, Feroz, retirement when it looms, you're in trouble. This completes a family of academic excellence, which brings him joy and laughter, as he admitted, every day. And he is immensely proud of the young women his daughters have grown to be. Other attributes of Feroz is that he used to support Man United until recently. And he also loved tinkering with electronics, basically Mr. Fidgety, and those of you who remember, he has MacGyver trays. He's also a notable musician and able to perform the renditions of Arjit Singh almost expertly as the master himself. In fact, in our strategic planning sessions, he has worn the wooden mic at the annually. He actually took over from the former head, Professor Kugen Pomal, but sings much better. He did tell me that his favorite dish was kebab and roti with mango acha and chicken tikka, although his culinary talents remain a mystery to most. Feroz admits that his journey through academia has been driven by deep-seated curiosity and a passion for mathematical modeling of biological systems. This passion has been nurtured by his mentors, Professor Ahmad Kassan and the late Professor Bharti Odav, who have guided him through the complexities of his research. Feroz boasts an impressive academic background highlighted by the attainment of a doctorate in technology from the Durban University of Technology in 2010. His educational journey also includes the completion of a Master's of Science degree with distinction from the former University of Durban-Westville, now UKZN, a Bachelor of Science Honours degree in 1991 and a Bachelor of Science degree in 1988 from the same institution. Throughout his academic career, Feroz consistently exhibited excellence and dedication to his studies. A notable point of commonality is that we pursued our honours and master's degrees together at UDW, now UKZN, in the late 1980s and early 1990s, and served as graduate assistants together. During this time, I came to greatly admire Feroz's focus on statistical approaches, which he used to substantiate his scientific findings. He also displayed cosmic ideologies, Alan, with deep black hole theories. Maybe that's why he entertained you. Professor Swalaha has been a dedicated academic and has built a remarkable career path, demonstrating strong leadership, scientific expertise, and a strong commitment and dedication in various roles at the Durban University of Technology. His career in academia began in 1993 as a senior research assistant, and where he focused on researching heavy metals bioremediation. His passion for scientific inquiry and innovative problem solving paved the way for future accomplishments. He joined Technikon Natal in 1995 as a senior researcher, and in 1996 he was promoted to senior technician. In 1997, he assumed the role of lecturer in Technikon Natal, marking another milestone in his career. He continued to excel in teaching and research, and his expertise and leadership qualities were recognized when he was appointed as head of Department of Biotechnology and Food Science at DUT in 2017. In this capacity, he played a pivotal role in advancing the department's goals, promoting quality teaching and research, and supervised high-powered teaching, learning, and research staff, the strongest and toughest academic unit of DUT. Without any doubt, I gave him a run and unrelenting support, and he delivered and continues to deliver. Feroz's dedication and strategic vision led to his reappointment as HOD in 2022, reaffirming his commitment to academic excellence. What must be noted in his mind map approach to rollout of solutions in his management armory, I'm not sure whether it was a smokescreen to create confusion amongst his staff or keep them thinking all the time. The other leadership change was his ruffled hairstyle and his three-piece suit over, or rather a dress over. I'm not sure what will happen after today. Throughout his career, Feroz has been instrumental in curriculum development, postgraduate supervision, and teaching. His commitment to online teaching and curriculum innovation has made a significant impact on the academic community, and his contributions to areas such as microbiology, bioprocessing, statistics, and research methodology have been invaluable. His NRF C2 rating in 2022 shows his class as a strong researcher in biotechnology, and more specifically in water technology. He boasts an outstanding track record of having graduated 10 masters and 7 PhD students, and is currently supervising 3 masters and 1 PhD student. In addition, his 6 book chapters and over 40 publications in international journals are truly exceptional. The metrics related to his research, Web of Science H-index of 12 and Scopus H-index of 14, demonstrate his solid leadership in his field. Feroz's career path is a testament to his passion for teaching, research, and leadership. His journey from a senior research assistant to a full professor to a HOD showcases his remarkable growth and contributions to the academic community. His exact words, and I quote, "As I look ahead, My goal in life and in research is to be a human being who is useful to society. I strive to be helpful to whoever is in need, and I hope that my work will contribute to the betterment of our world. In closing, Professor Swalaha, thank you for your support and leadership and being a great science ambassador. May you continue to achieve great success in your research endeavors and continue to create waves and liquefy your future and our future. And the Faculty of Applied Sciences welcomes you to its cadre of 10 inaugurated professors. Good luck and reach for the stars. And I welcome you to the stage.
Good afternoon, ladies and gentlemen. I wish to say welcome to everybody who have joined us today, especially our Vice Chancellor, our Deputy Vice Chancellor, and the other in absentia, and especially to our Executive Dean. That was an extremely unusual summary of my life. Yes, I did entertain some of Alan's somewhat unusual theories as well. And what he failed to indicate was the fact that I had managed to disprove some of it quite early on. So, yes, I called a favor in to ask him to do the introductions today. So thank you, Alan, as well. And I'd like to thank my family for joining us today as well. And all of my department as well, and I'm going to acknowledge you a little later on. But on to today's lecture, which is supposed to be my inaugural for today. And my topic is improving water quality for a liquid future. So I think I don't need to introduce myself. Many people have introduced me already. Unfortunately, we are in the midst of a crisis, and we know this already. Over 2 billion people worldwide do not have safe drinking water. And in South Africa alone, we have roughly about 19% of our rural population that does not have drinking water available to us. That's approximately 14 million people. And large amounts of pollutants are entering watercourses, leading to serious impacts on the environment, which implies then that we have some role to play in the research and development of technical solutions to be able to deal with these. Sometimes we are unable to recover, leading to catastrophic and irreversible environmental disasters. And you will notice in the background, that's the Durban skyline, by the way. These things are happening in our backyards. And these are all precipitated by man-made activities, unfortunately. So we as human beings need to be able to solve these problems as well. So hence the title of my talk, by the way. And some of the contributing factors. In South Africa, we have a further challenge of rapid urbanization, uncontrolled development in cities that leads to far greater strains on the reticulation system, as well as the treatment systems that we have. And we are simply unable to cope with the massive increases in demand for water in this rapidly developing country. And some of the consequences have been clearly seen in our city with the failure of pump stations, leading to raw sewage being pumped directly into the oceans. You can see these pipes. By the way, pipes that are leading to our oceans, the Indian Ocean. And a serious consequence of this is the increase in hazardous levels of pollutants and pathogens to humans that have a direct effect on human health. And a week or two ago, we had an algal bloom on the north coast of Durban, which was due to nitrates and phosphates entering into the ocean. So some of the contributing factors, have led to some of these issues that I show now. These are all pictures of areas around Durban. That is the Umgeni River, close to the mouth. We have pollution upstream, most likely wastewater treatment plants, failing to discharge correctly into the environment, leading to high amounts of organic and inorganic pollutants, encouraging rapid bacterial growth in the rivers themselves. You can see that the water is quite murky. This has the unfortunate effect of using up all the oxygen, and the fish that are in the water themselves actually drown. Yes, fish can drown in water if they don't breathe. This was in 2022, by the way. In 2023, we've had raw sewage being discharged directly into the ocean at the Cuttings Beach near Merebank. Unfortunately, humans think the ocean is a dumping site. So these occurrences are common across the planet, not just in South Africa. Raw sewage in recreational and fishing beaches lead to entire areas being so polluted that it cannot be used for weeks or months afterwards. And the sewage usually ends up washed up on the beaches, requiring physical cleaning on the shores. And we've seen this already in our Durban beaches as well. Diseases like hepatitis and cholera are also carried into the ocean and may be picked up by eating seafood caught from these areas as well. And this is a 2023, December 2023 headline, by the way. This was during the peak holiday period where we've had swimming off limits at the Durban beaches. And I want to show you why it has been off limits. Approximately 130 would be the actual requirement for swimming to say it's an excellent or an acceptable amount. Some of these amounts have been approximately 1.2 million in our watercourses. Okay, so, and all of them have failed, by the way, upwards of 300,000, 400,000. This is results from the 11th of December 2023. So we have a genuine problem in our areas, and it's not just that. We have issues around potable water as well. We have had areas that have been without potable water for quite a long time, and in my chat with some of my staff members, they brought to my attention the fact that there has been water shortages in the Mkambatini, Kwazimba area since 2018. There has been no water available in the pipes, and it has not yet been fixed, which has led to protest action across the way. In Verulam recently, and I think it was in the Sunday Tribune, there was an article that indicated that the Verulam community has been without water for over 150 days now, and they've now approached the UN as an intervention for human rights related violations. Speaking of the UN, so what do the world organizations then do about the degrading quality of water? Well, they just set goals. And unfortunately, we have to meet with these goals. So one of them is to provide clean water and sanitation. And I mentioned earlier on, up to 19% of our rural population doesn't have access to clean water. To improve access, we need to be able to provide infrastructure. And unfortunately, increasing efficiency in all sectors, be it policy, maintenance, delivery of quality, and testing. The Mercury yesterday morning indicated that we are now going to be tightening up on people in political situations who are not meeting their requirements in the water sector. We also need to be able to manage resources, and our resources are inextricably linked to the fact that we pollute so much. The rivers, the groundwaters, etc., we get from in South Africa, we are having a serious issue with regards to accessing them. South Africa, by the way, has a global rainfall average of about 464 millimeters, and the world average is about 990 millimeters. This unfortunately means that we are a water-scarce country, and we need to manage what resources we have at our disposal. And when we have them, we need to protect and restore them if we pollute them. And this is where the research comes in. We also need to be able to assist communities to better use water in those areas. And we need to be able to improve technology, which is where the researchers come in. Okay. Apart from that, we have to support local communities such as the industries and agriculture to be able to deal with some of the water-related issues that they have, particularly with regards to pollutants and their dumping into the environments. And I'll be speaking a little bit about this later on in my talk. Unfortunately, this is all time-based, and it's time-based up to 2030 by the UN. That's a mere 6 years from now. It seems a little far-fetched. So what is needed? There's an urgent need to develop technologies for the treatment of pollutants in water in order to restore the safe supply of water and to prevent the degradation of the environment. And also there's an urgent need for innovation and out-of-the-box thinking. By the way, we can only think that far out of the box. There are several restraints. And I'm going to show you some things about restraints and thinking out of the box in a little while's time. So to the right, there is a water condensation system that can produce unlimited drinking water. And we are able to do this now, and we need to be able to make use of these technologies. The air conditioners that run this room, for example, are actually producing condensed water, which is quite pure and potable. We are not tapping into this. Okay, so, we're going backwards. So my journey in the water sector it's crucial in terms of research. Research in the water sector requires that we look at various subsections. Things like water scarcity. I already mentioned what the precipitation rates in South Africa is, and the fact that we have scarce water. The water quality, we need to be able to monitor and assess water to be able to identify new pollutants as well as the microorganisms that are in them as well. This leads to waterborne diseases, the sources, the tracking, and the control, and some of our research is going to be addressing this as well, which I'm going to talk about. We also have one of the largest users of water in the country, that is agriculture, and this leads to issues around food security. Recently, we've had food security issues in the peanut butter industry, producing aflatoxins. We need to be able to innovate and produce new technologies for new purification, treatment, and reuse systems, things like desalination systems. We need to be able to improve the ecosystem health, develop infrastructure, and maintain that infrastructure. Unfortunately, we have a situation in this country where we have infrastructure being degraded rather rapidly. Unfortunately, we don't live in a vacuum any longer. We have to have global and local collaboration as well. And we need to look at policy and governance as part of our solutions as well, because these are inextricably linked to the problems that we have in this country. And overarching all of this, we have to look at things like climate change. So when we have all these issues, we have to ask, for example, what degrades water? And some of the things that degrade water are industrial pollution, improper waste disposal, mining activities, agricultural runoff, oil spills, atmospheric deposition. And we have also wastewater disposal in terms of urban runoff. You saw a picture earlier on of plastics entering the ocean. By the way, this is the Great Pacific Garbage Patch. Okay, it is 1.6 million square kilometers that spans the coast of the United States and the coast of China. Okay, and there's actually an eastern and a western subsection to this Great Pacific Garbage Patch. It is filled with floating plastic. Okay, and this is something that we need to be able to address when talking about our research into water treatment and wastewater treatment. And along with this comes climate change in terms of erosion and sedimentation. We'll talk a little bit about that as well. So my primary areas of research included pollution treatment, including heavy metals. I think Prof Singh alluded to that, and organics and inorganics treatment. We looked at waste treatment in terms of urban runoff. We looked at wastewater reuse in terms of valuable byproducts. And we also looked at hazards monitoring, including bacterial and viral indicators. So I'm going to expound a little bit about that in my little journey in research. I've been able to focus on a few things only, unfortunately. In terms of heavy metals, we used heavy metals from wastewater to treat water. We used the waste materials, which are the activated sludges. We unpacked the science for metal absorption on biological surfaces. And these are actually domestic and industrial sludges which are dried, which were used as adsorbents. And the polysaccharides from these sludges were also used, along with the individual bacteria that we were able to utilize. This was part of my master's degree that we did a long time ago. Some of the people that I worked with, my supervisor at the time was Professor Hemant Kasan, and Professor Bucks was continuing with this work as well, and he's the current head of IWWT. So we looked at various methods. There are various methods, including physical, binding to proteins, ion exchange, precipitation, and even enzymatic conversion, which I'll talk to you a little bit about later on. The sludge metal components absorbing metal included things like extracellular polysaccharides, and these absorb more metals from wastewater than the actual sludge itself. There were 7 bacterial species. I'm not going to go into all of them at the moment. And industrial sludges were able to remove more toxic chromium-6. By the way, remember this, chromium-6 is a more toxic form than chromium-3. And we found that purified EPS had a higher capacity for absorbing heavy metals, which was one of the solutions we proposed for cleaning water. And this was my introduction, for example, to mathematical modeling, where I was introduced to the Langmuir isotherms to be able to describe microbial interactions with heavy metals. And these all indicate different types of interactions between microorganisms and heavy metals. And we are able to then describe these. I'm not going to go into any great detail with unpacking these. Later, we looked at the enzymatic degradation of heavy metals, and actually what we found was an organism, not one organism, but a few organisms which produced chromate reductase, which was capable of reducing chromium from chromium-6 to chromium-3, which is able to precipitate out of solution and is able to then not be as toxic as chromium-6. Chromium-6, by the way, is a carcinogen. The chromate reductase, by the way, was used in upflow packed bed columns with immobilized bacterial consortia. And we had 4 genera being used, including Pseudomonas, Bacillus cellulomonas, and Acinetobacter. All significantly reduced chromium, with Pseudomonas matrophilia being found to have the highest chromate reductase capacity. We had reductions of up to 99% and quite a high rate of chromate reduction, along with the fact that we were able to unpack some of the processes that occurred, including the fact that these enzymes were localized in the cell membranes and they were constitutive, which meant that they were being produced regardless of whether chromium was present or not. And unfortunately, they required NADPH, which implies that they required energy to be able to operate. We were able to significantly reduce chromium from approximately 150 milligrams to within acceptable standards. This is one of the organisms that we found high chromate reductase in, just Pseudomonas baltifila, which is the green line that is indicated here, which outperform various other organisms. We also looked at imported biomass because people were starting to make claims about their biomass that came from other countries. So we brought them down into South Africa, and this was a water research project. And we found that things like Bacillus subtilis performed the best of the patented biomasses. We subjected them to multiple adsorption and desorption cycles in order to try and see how they would fail. And both the Bacillus and the Citrobacter species were combined, and we tried to challenge them with industrial wastewater. The industrial wastewater were actually done at an industry called Natal Electroplaters in one of their drag-out baths. And these columns were able to perform quite admirably, going up to 14 or 15 cycles with various heavy metals being removed before they were failing at around 50 milligrams per liter. We were able to even find that these organisms were able to go up to 24 cycles in these columns before failing. So these were quite significant results. And I want to conclude some of these now. So we found various microorganisms and their components that displayed heavy metal binding and removal capabilities. We also found mechanisms, and we were able to describe them mathematically, and we were able to determine some of them being either enzymatic or surface adsorption, etc. We also, I mentioned descriptive modeling that we did. One of the other things that we looked at in terms of heavy metals and in conjunction with other organic materials was wastewater treatment in terms of urban runoff. Urban runoff normally is produced by very often informal settlements that are situated close to rivers, and these produce runoff that enters directly into the rivers, which will theoretically be able to pollute those rivers to a level that they may not recover from. So our solution was to develop these constructed riser filters, and this constructed riser filter actually is a box. Literally, we were talking about a box. We talk about boxes in sciences, black boxes, for example, and this one was actually populated with two species of plants. One was Phragmites australis and Kailinga nemoralis. The other was Kailinga nemoralis. We were then able to determine the effect of the rhizosphere underneath the soil, along with those plants, to be able to remove heavy metals and pathogens and other pollutants as well. So in a controlled environment, we were able to tell how well these things operated. And we found that these systems, as particularly the planted sections, were able to absorb various heavy metals, including lead, by the way. And we were able to find pathogens being removed up to 98% efficiency, including Salmonella, Candida, and E. coli. And we were able to find Ascaris lumbricoides. I'll show you a picture of Ascaris in a little while's time. And as scientists, we like to go into great detail. So here's some SEMs, which is scanning electron micrographs, that go into the absolute detail of the leaf structures. And the pictures below actually show you any energy dispersive spectroscopy to show you where the actual metals are attached to the leaf structures. And these make some very pretty pictures. We had to decode them as well. The nutrient removal included nitrates, phosphates, and ammonia, and you could see with the green lines that the planted sections were able to significantly outperform the non-planted sections. We were able to remove pathogens as well, including Salmonella, Candida, and E. coli, and all of these performed better in terms of the planted sections of the riser filtration system. We also looked at ascarid over-reduction. By the way, Ascaris is a parasitic worm in humans, infecting approximately 1 billion people on the planet. And to be able to remove those ova is a significant thing from these systems. And you can see the green lines compared to the blue lines are when the planted systems were able to significantly reduce the ascarids. By the way, these are the ova. They are quite refractile bodies. You can see them quite easily under the microscope. And this is what it looks like when you have a severe ascarid infection, and we have to open you up and cut into your jejunum and pull out the ascarids. So they're quite an insidious infection. Some of the conclusions, we were able to look at these complex environments and unpack the pollution removal potential of these environments. We looked at inorganic and organic pollutants, and we found that they were significantly removed. Pathogenic bacteria, the technology I already mentioned, has applications at river edges bordering informal settlements. We can easily harness complex microbial plant interactions to remediate virtually any polluted environment. One of the other things that I want to touch on is wastewater reuse. By the way, that's not an ascarid. We were, in order to do this, somewhat of a mind map. I'm going to speak about it. We were able to identify substrates such as edible oil effluents, I'm going too fast, anaerobic digestion wastes, and flue gases. And we were able to screen and identify organisms by mutation, growth optimization, etc. And then we developed feasibility studies to determine the efficiency, practicality, and the costs of these processes. And we also continued process development, in some cases up to pilot scale, in terms of product purity and scaling up. One of the things that we did was riboflavin from edible oil effluent. By the way, riboflavin is vitamin B2. It's a $451 million market in 2024. Edible oil effluent in South Africa is produced at approximately 1.75 million metric tons or meters cubed per year. And we were able to look at 4 different organisms producing vitamin B2 from oil effluents, and 2 of them were of particular interest, Ribothium gossypii and Candida formata. And brute mutation of these organisms increased production by approximately 11-fold, and media optimization using statistical modeling increased the organism's production by a further 3.5-fold. The market estimated in 2010 when we did the study was approximately 63.5 million. I wonder what it is today. I want to acknowledge some of the people who were involved in the conceptualization and supervision of the study, which was Professor George Tivcheb and Professor Bharti Odav, who is unfortunately late. Again, we looked at the riboflavin producers, and we're able to do epifluorescence on these. These are actually the same photograph under light microscopy and epifluorescence, and we were able to show the localization of the points where riboflavin is produced. You can actually see the fluorescing of these things. We did riboflavin optimization with statistical designs, including design of experiments. We used fractional factorial experimental designs, and a response surface methodology with central composite designs. I like to go through the entire process with my students and teach them the right way of doing things. Using erythrithium gossipy, and then we were able to confirm the entire process, all the while developing this quadratic mathematical equation to be able to describe it as well, and then confirm it as well. So it makes for pretty pictures, I know. And we also were able to do some spirulina production. By the way, spirulina is a supplement that human beings use. We were able to do this in paddle bed bioreactors, one of the earliest ones, by the way, that we were able to develop. This is what spirulina looks like. And we were doing some optimization studies as well on it, and I'm not going to bore you with the great detail around optimization. Safe to say that we were able to produce over 1 gram per liter of spirulina in solution. And this was powered by sunlight, by the way, including the bioreactor itself. We went on to look at methane from industrial wastewaters as well. Methane is an energy source that we can burn to be able to grow, to be able to heat the process of treating industrial wastes. And this included anaerobic digestion for processes. And this was a process that was first optimized with COD, temperature, and things like hydraulic retention time. By the way, hydraulic retention time is the amount of time that water or the wastewater is in the system before it moves out after it being treated. Okay, so several input and output parameters were identified, leading to the need for a more complex mathematical model. We developed a combined Pareto differential evolution model, which is abbreviated to CPMDE, and it was developed to optimize the methane production. We are also able to unpack a large amount of microorganisms, including protea, bacteria, members of the Firmicutes, chloroflexi, and various archaeobacteria that were in the process, and as they developed through this process. And from the CPMD model, we developed a modified kinetic methane generation model with a Stover-Cannon kinetic model. And the efficiency of COD removal was improved as a remarkable 87%, and hydraulic retention time was reduced by approximately 25%. So that is quite a significant amount when we talk about a 24-hour running process. Methane was also produced at approximately 5 grams per liter. And obviously, we had to look at the model, and I'm not going to go into too great a set of details. Safe to say that the input and output parameters produced this modified methane generation model, and we were able to develop some of these predicted and actual trends which were confirmed by experimentation. Like I said earlier on, the microbial communities, this was one of the first time that the microbial communities in a upflow anaerobic sponge blanket reactor, by the way, it's cut off, sorry about that, were unpacked, literally. We went on to produce a blue pigment called phycocyanin from algae grown in wastewater. And this is we found a hypersaline alga, which was able to tolerate high concentrations of salt. It was from the Euhalothiaceae, and we found it to be a novel species, by the way. And we again used RSM to optimize growth conditions before phycocyanin production, and I'm going to only show phycocyanin production. And the key genes in phycocyanin production were also elucidated. And we purified and optimized these processes to produce a stable pharmaceutical compound. And we obviously had to look at the structure of that compound because we are scientists. So the OFAT experiment, oh, by the way, one factor at a time is OFAT. And some of the OFATs that we used included sodium phosphate, thawing times, biomass buffer ratios, and by the way, this is a scanning electron micrograph of the Euhalothes species that we produce. So here come the colorful pictures again. These are contour plots. These don't look as good as the three-dimensional plots, but they are scientifically more accurate to show because they give you the target points, and you can actually see the target points on these, and you are able to describe them more efficiently. And obviously, the purity of these organisms were quadratically described as well. And as scientists, like I said, we were able to unpack the structure of this, the ficocyanin. It's actually a hexamer, and we haven't shown the structure of the hexamer in this process. We went on also to look at novel uses for algae in directed CO2 sequestration. Instead of the human being there tracking your algae, we used chlorella species. We were able to assess their CO2 absorption rates. And one of the unusual things that we used was the photosynthetic efficiency of these algae to find out how well these algae were performing. Because the greater the photosynthetic efficiency, the better the ability to absorb carbon dioxide. And we also looked at abiotic parameters such as light intensity, diurnal cycles. Diurnal cycles are the light and day times. And nutrient concentrations were optimized using response surface methodology. And the chokerzone organisms that we found were highly tolerant. The organism we found was a highly tolerant CO2 tolerant chlorella species. And we tested this in a pilot scale flatbed reactor, and it was able to absorb approximately 0.8 grams per liter of CO2. And a byproduct of the process was biomass, which we could use later on, approximately 3.4 grams per liter, which is quite high for algae, by the way. And so this is what flue gases look like, by the way, for those of you who have been wondering. And this is what we were able to trap in these algae at quite an efficient rate. And when assessing the carbon tolerance, by the way, we were able to assess it based on something called the maximum quantum yield, and also the fact that these actually it's a difference between the photosystem 1 and photosystem 2 of for photosynthesis, and we are able to determine, for example, how well these algae perform under stress conditions. The dotted line is healthy algae, and as we increase the concentrations of CO2, the algae obviously become less and less healthy. It's like human beings. If I had to flood this room with CO2, you're probably going to get less and less healthy until you die. So some of these were assessed using these bubble plots. We also, and there's some more pretty pictures with central composite design, and we were able to describe, for example, the growth of the algae in terms of biomass with quadratic equations, and be able to target, for example, the concentrations of the chemical compounds that we were able to grow these algae with. So just to conclude, some wastewater can be reused to produce valuable products such as vitamins, food, and pharmaceutical products. Energy can be generated from wastewater using microorganisms to close green cycles. Carbon can also be sequestered from environments with microbial biomass, and these biomass can have other applications as well. And we are not, at the moment, tapping into the enormous potential of microbial factories at our disposal. One of the things that I also want to introduce is hazards monitoring in water. This is an adenovirus, by the way. It looks like a bit of an alien, but it's actually in everybody's noses right now. It causes the common cold. We were looking at adenoviruses in the Mzinduzi River and the effect of anthropomorphogenic activities, which means humans. And the humans that were using this river were the people who were paddling in the Duzi Canoe Marathon. So we were able to track, for example, how the humans increased the amount of adenoviruses during the Duzi Canoe Marathon. And we were able to then show, for example, how the river remediated itself in a little while after the canoe marathon. And we didn't do just this for adenoviruses. We did it for hepatitis A, by the way, which is a highly transmissible hepatitis virus that comes through water. And it showed a marked increase in hepatitis during the canoe marathon. This is prior to, during, and after the canoe marathon, by the way. But the river was able to recover itself as well. And we also looked at noroviruses, and we surveyed them in the Mzunduzi, and we found that some of the noroviruses were able to accumulate towards the latter part of the river during the race. And we also looked at rotaviruses, which are a highly infectious virus causing severe dehydrating diarrhea in infants and people who have immunocompromised immune systems. And also elderly people. By the way, that's a very pretty picture. It's stylized. It's not actually how it looks. So what do we do about these? So one of my students decided that he wants to look at plant materials. And these are 3 plants: Spondius, Mombin, Macaranga, Barterai, and sesame, from which we were able to identify approximately 77 compounds. And we challenged them with VP5 and VP8, along with Prof. Sabiu Said, which are subcomponents of the VP4 trimer, which is on the surface, these red things that are growing on the surfaces of rotaviruses. This is rotavirus A, by the way. Molecular docking experiments of these 77 compounds were done, and we looked at also absorption, distribution, metabolism, excretion, and toxicity, abbreviated as ADMET. And we found 2 chemical compounds, sericetin and apigenin, which had affinities for rotavirus and activity against the VP5, the virus protein 5, and the VP8. Which was better than the actual reference standard. And the reference standard is something that we use to treat rotavirus. And so if you find plant compounds that are better than the reference standard, theoretically we are able to produce a better chemical to treat them. And this was done with some molecular simulations, and this little pretty picture shows some of the molecular simulations. There are quite a few. I'm not going to go into any great detail. So some of the conclusions. We had strong correlations between fecal indicator bacteria and coliphages in those rivers. We had poor correlation between indicator bacteria and viral pathogens. And one of the universal indicators was identified as adenoviruses, which are in the noses of most human beings, by the way. There was quite a bit of variability due to pathogens and geographical locations, as you could see. Pathogens prediction may require a suite of indicators, and we are still involved in the study along with Afghani water at the moment. There are treatments available from the natural environment, and we just have to find them. And so what's next? We are talking about a liquid future. Old tactics do not have the applicability in new environments. Centralized water treatment is often the least advanced of our technologies at the moment. Some of it is 60 or 70 years old, and we are still using it. And that is why much of it is breaking down. Hierarchical approaches slows maintenance and upgrading. And that's unfortunately what we are seeing with regards to supply of water and treatment of wastewater. Decision making is centralized, leading to long delays at the moment. And we can see the fact that if there's a water outage, we tend to wait a long period of time. And I've shown you some of the people protesting due to the fact that they've been waiting for years and years. Water integrity needs to be strategized to be at the top of the political agenda. And think about this when we are at the next election. We need climate-sensitive solutions to ensure longevity of systems. And unless we do all of these things, we're going to have to join that rocket and leave the planet. So doing things differently, I wanted to just show us something that Prof. Singh is very enamored of. This is a fellow that has been just passed by 4 people. And we were talking about thinking out the box, using the same kind of equipment that we have. This person now has reduced his drag coefficient by 68%. He's not pedaling his bicycle. He's not even using his equipment properly. What's he doing? Okay. So this is unfortunately the thing we have to do right now. And by the way, he's also impressing the ladies. So, right, so anyway, sorry, let me just move on. So we need new rules, by the way. Who would have thought that we are paying for drinking water these days? There are now service providers on every street in most suburbs selling purified water. We have serious problems, though, and the quality of the services being provided for in terms of purified water and purified water needs to be benchmarked in terms of standards. We need fluid responses to water availability, and treatment is needed. So what are the solutions? Traditional large-scale systems for supply and treatment are breaking down. Unfortunately, we see these tankers at regular intervals. We are now ending up with tanker consortia that are breaking down the water system so that they can now provide us with tankered water. This is creating more problems. Maintenance and building new systems are expensive. We need to be able to decentralize opportunities to treat at community level, and we need to be encouraging this. Things like drilling boreholes at the community level need to be encouraged. Okay, this will ensure tactical nimbleness, speed, and cost effectiveness of our treatment processes and our supply processes. In terms of decentralization, it has various advantages: spreading out risk, building redundancy, diversifying technologies, incrementally growing systems as needed. And we need to be more flexible. These things need to be more flexible to change, and it very often happens that decentralized systems tend to be far better at adopting new technologies, by the way. We are the researchers who need to be able to provide those new technologies. And I'm going to go on with solutions because there are many. We need more supplies to provide varied options as in the energy sector. These are, by the way, roof tiles that are solar powered. We're now having solar panels being stolen off roofs, and we need to be able to incorporate them into our roof tiles. I think Elon has developed some already, but these are actually in roof tiles at the moment. Things like bottled water on demand, especially in disaster areas, borehole water in communities to be able to supply during situations when they are unable to get it from the municipal system, home filtration systems to be able to provide our water, purified water from rainwater. We need scale systems for differing community sizes, such as informal settlements or large estates. By the way, this is a scale system that can theoretically be producing water for any size of community. Okay, larger scale filtration systems can be it will provide larger communities with pure water to drink. Our point of discharge in terms of purification at industry and domestic level needs to have some form of treatment so that our wastes, our natural resources do not get degraded as they are currently. We need to find new solutions to be able to do so, and that's where the research comes in. So with solutions come problems. I already mentioned one, by the way. Sometimes the service providers that are providing these solutions are strictly profit-oriented. Can we create a model that is community-driven rather than company-driven? We need to be able to address communities to be able to develop their own technologies such that they have a vested interest in what they are providing themselves. Okay? And very often they will not be charging themselves a large amount of money. Can we incentivize community self-reliance through subsidies? And sometimes subsidies drive up costs, I understand this. But this is one of the ways in which we can incentivize communities. And by the way, this has already been done in the energy and transport sectors. Think about the fact that very few people actually take buses anymore, and very few people actually take trains anymore. The taxi industry developed from the community. Okay? And the energy sector, we now have several different people providing us with solar power and generators and you name it. Okay, so these are sectors that are developed in response to needs, and unfortunately the need for water is coming. It's coming, it's already here. So what about the future? In terms of prediction, we need to have visualized solutions to problems. For example, predicted outages. This, by the way, is an artificial neural network model to predict weather. We'll be able to adapt these to predict outages, spills, and spread and containment of these spills. We need to be able to predict hotspots such that, so for example, socioeconomic conditions in particular environments when they are changing, urbanisation and its effects, future planning for systems, disaster management strategies when they happen, and we've had several disasters in KwaZulu-Natal thus far. We need to have pro-action rather than reaction, and this unfortunately falls into the hands of the scientists and obviously the policymakers afterwards. Unfortunately, the scientists don't communicate very well with the policymakers. We need response planning for future issues. And I think I'm going to stop there. I'm not sure how far I've gone. Approximately 43 minutes. So I want to acknowledge some people before I close. People like Jabu Mavundla, who have organized this, Jerry Sylvester and Morgan, thank you so much for being part of the process. These are the small people who make the cogs run. Alan Khan, yes, I've said thank you to you already. Our Vice Chancellor has graciously joined us today, and our DVC RIE, who has joined us as well. Our Dean, who has given me this humorous introduction, thank you so much, and the other deans and people who have joined us, all the distinguished professors, thank you so much for joining us as well, and my staff and students as well. So I want to particularly talk to my master's and doctoral candidates. I want to say thank you so much to all of you, and some of my postdocs who are attending online as well. So I've already mentioned my colleagues. Some of them I want to mention by name: Dr. Sham Ram Lakhan, who has retired now, Mr. Hari Nalasmulu, who has left duty, Professor Faisal Bucks, who is sitting in the audience at the wall, Prof. Hemant Kasan, Professor Bharati Odav, who is late, and Dr. George Tuvchev, who has left the university. I want to also acknowledge my exceptional department. Their professionalism and dedication to excellence makes it easy to head this group of over 25 people. I must say thank you to all of you, from the secretaries to the professors. Their achievements showed this annually, and I want to say thank you to you guys for supporting me. The funding bodies that I want to thank are indicated, and particularly I wanted to thank my family, particularly my parents. I think Suren did a very good job of, so I'm not going to reiterate. I want to thank my immediate family for joining me. I have my beautiful children who have joined me today, and my wife, who is hiding. And I want to also thank my extended family for joining me as well. Thank you so much for my brothers and sisters for joining me today for this talk. Now you know a little bit about what I do. So I wanted to end by saying that water is the most abundant molecule on the Earth's surface, and water, along with human nature, has the ability to do tremendous harm by destruction, just like human nature, or tremendous good by growing and nurturing and developing humanity, depending on how we use or abuse either water or human nature. Okay? It is vital that we use this resource well, and we also use our natures well to be able to increase the good, the greater good in society. And we must not just mankind, by the way, we need to look at the entire planet as well. Okay, we owe it to our world to be able to be good to society. Okay, and I want to say thank you so much for your attention. Okay. I do believe we may have a few questions.
Thank you so much to Professor Swalaha. That was insightful. I think most of us knew you were clever, but we didn't know you were that smart. Because the presentation, I learned a lot. Okay. And maybe I can get the questions going.
Go on.
Is it true that water on our planet arrived in comets and asteroids?
I wonder where this is leading to. I think I'm going to have to disprove certain other theories. But I'm not going to do it in public. We'll have a private discussion.
Right. Well, I tried. I mean, I thought under the pressure of the Vice Chancellor being here and
yes,
the DVC and the Dean, Executive Dean, maybe you'd cave in to say yes. All right, so I've got a roving mic. If anyone has a question, you can just raise your hand and we'll take a few questions.
Yes, go on.
For clarity. Any questions? No?
He's clapping me off.
Professor Labara? Ah, okay. Professor Darren Lawton? There we right. Hi, Darren.
Congratulations first.
Thanks, Prof.
One of your first slides dealt with the water quality in the eThekwini municipality. What, if any, recommendations do you have to get the people who govern the city to take this work ever so slightly more seriously?
I think it requires us to be a bit more active in the community. It requires us to be able to interact more with the, like I said, the policymakers. We need to take a more active role in the community, in the policy and development of provision of water and wastewater treatment resources in our communities. We cannot step back anymore. We have to step forward. We have to be able to provide, for example, some of the solutions, and not just some of the solutions, we have to develop some new solutions to current problems. I also already indicated that there are quite a few, but I think without human interactions between individuals, we are not going to be able to drive this process. So unfortunately, we're going to have to step forward and take the stand. And I'm going to put myself first as well. I'm going to say I'm going to be a bit more active in this as well. We've been doing this on our community level, but I think we need to step up a little bit and move to the policymakers as well. So I hope I've answered your question.
Thank you so much, Professor Lawton, for the question, Professor Swalaha for the response. Any other questions? Going once? Twice? 3 times a lady. A nice song, by the way. So I've got one quick question. So nothing to do with asteroids and meteorites. So we have groundwater that sits underground for centuries, correct?
Yes.
Why is it that Aquile and Valpre pull it out, stick it in a bottle and say, best before July 2024, after it's been there for hundreds of years? Is it the plastic?
No. These processes don't necessarily completely sterilize these water bottles. They have a small amount of microorganisms in them, and these microorganisms grow over a period of time. So hence, after a period of time, you're going to end up with some contamination that is going to probably not be good for you, along with the microplastics as well, by the way.
All right. Okay, so now I know. Thank you very much.
You're welcome.
Last night, I asked my friends at ChatGPT, please write a poem about Feroz and water. Clearly I was bored, it was load shedding, I got the app on my phone. And lo and behold, it said, in the desert, Feroz did dwell, where water was scarce, you could tell. But Feroz, oh so sly and quick, had a plan that was quite slick. He danced and pranced with a grin, to every puddle he'd dash right in. Splash and splish, he'd make a scene. In water he felt like a king so keen. His friends would laugh at his spree, saying, Feroz, you're quite a sight to see. But he'd just wink and carry on, for in water's embrace he felt so strong. See, here's to Feroz, the desert's joker. With water antics, he's quite the looker. In parched lands, he brings the laughter, for Feroz and water is happily ever after. ChatGPT. What do you think? Not bad, right? Artificial intelligence, water, Feroz.
Yes, Alan, very good.
Vice Chancellor, ladies and gentlemen, please give a round of applause to Professor Feroz Mohammed Swalaha. Feroz, before you go, I'm going to ask the Vice Chancellor to hand over a small gift to you, and we'll get the photograph, get onto the shot.
Sorry. I'm just going to shut that down.
In case you're wondering, it's a lovely water bottle. No, I'm joking. It's not. I don't know what it is, actually. But yes, by all means. Thank you so much. Thank you, Feroz. Right, let me move back to the podium microphone. So, Professor Swalaha, when you played the video of the cyclist, and the drag coefficient of almost 0. Professor Suren Singh got so excited because those who know that when you put a bicycle and a man in hot pants who's cycling, and especially doing what that cyclist did. So Professor Singh, my friendly advice, I know you're going to try this out on Saturday morning, cycling down the M4. Just make sure you have a padded seat, because I'd hate for you to injure your water treatment plant, okay? So, ladies and gentlemen, as we draw to conclusion for tonight's auspicious inaugural lecture, I'd like to invite the Deputy Vice-Chancellor, Research, Innovation and Engagement, Professor Nemavola, to deliver the closing remarks. Professor Nemavola.
Thank you very much. Program Director, Mr. Alan Khan, Vice Chancellor, and Principal Professor Tandram Tembo, our special guest, Professor Feroz, Swalaha, and your family, members of the executive and senior management present here, executive deans, Prof. Olubara and Prof. Singh, distinguished guests, esteemed colleagues, students, ladies and gentlemen. Good evening to you all. In fact, before I start, I actually had a question for Professor Swalaha. It's actually a very fundamental question. So when I think about water, I think about air, the air we breathe. And we actually pay nothing to breathe this air. And the question I have is, why should we pay for water? It's not a political question, by the way. Yes. So maybe it's something that we need to... So as I was going through the body of work of what you have been doing, I actually came across with something that got me very interested. And as you know, and all of us go to see medical doctors, physicians, and you will agree with me that it's very rare that you walk out of that room without some prescription of antibiotic. It's actually very rare. And when I see that you have been working, and I hope you still remember, because, you know, as academics, sometimes we have this problem of writing and forgetting about what we wrote 5 years down the line. But really, what is important for me is that, you know, all these biotics that we consume may end up in water, wastewater. And of course, those of us who are in cities, urban areas, will have to drink water from this wastewater treatment plant. And the work you did around how do you actually remove some of these antibiotics, because if they are not removed, they may actually cause more problems down the line, some kind of resistance and so forth. So I would like to thank you for the work that you have done. And thank you very much for sharing with us the work that you have done. One of the important thing about this lecture is to be able to explain in detail what you have done, especially to the family, because sometimes it is very, very difficult to explain to your daughter, your son, exactly what you do. But I think this is very, very useful. So colleagues, as we conclude, Professor Feroz Swalaha illuminating inaugural lecture titled Improving Water Quality for a liquid future. This was indeed a thought-provoking presentation, and of course it shed light on the crucial role we all play in protecting or safeguarding this life-sustaining resource. I am reminded of the values and principles that guide our work here at DUT, and I have no doubt that Professor Swalaha's dedication to water quality research embodies the ideals of transparency, honesty, integrity, respect, and accountability. His commitment to solution driven by fairness, professionalism, passion, and a drive for excellence amplifies the spirit of our institution. Of course, his work highlights the necessity of innovative approaches to safeguard our water resources, a true testament to our collective commitment to addressing global challenges. As we know, water scarcity is a serious problem. And clean water, just what you've showed us, just access to clean water, it's a serious challenge in our communities. This pursuit of a liquid future demands not only technological advancements, but also steadfast adherence to the principles that shape our action. I must indicate, Prof. Swalaha, that I'm thrilled to see such dedication to addressing these global challenges. Professor Swalaha, as research, not only holds immense potential for our region, but serves as an inspiration to aspiring scientists and researchers across the globe. So let us all, students, researchers, and members in the faculties, actively engage with the research presented here today by you, Professor Swalaha. May it fuel conversation that spark innovative solutions and inspire greater collaboration, Prof. Bucks, all while upholding the values and principles that define our university. On behalf of Durban University of Technology, I extend my sincere gratitude to you, Professor Swalaha, for your invaluable contribution today. We also appreciate the work of the organizing committee for ensuring the success of this event. And additionally, and this is very important, I would like to thank your family for supporting you throughout, so that you are able to be given space, time to do what you do and to do what you do best. Thank to all of you, the distinguished guests, colleagues, students, for your presence and participation. As I conclude, I would like to say that let us honor our shared commitment to a secure future guided by the principles that make our endeavors both impactful and honorable. I think this is important. The work that you have done really touches all of us. Children, mother, daughter, the pastor, all of us. We have no life without water. In fact, we have no life without clean water. So thank you very much, and keep up the great work that you do. Thank you very much.
Thank you for those wonderful words, Professor Nemavola. Professor Nemavola mentioned Professor Swalaha's family, and not on the program, but they want to say some words So your two lovely daughters, Nasia and Nafisa, is going to join me on stage. Don't look so worried. You're probably thinking, what are they going to say? So let's give a round of applause to Nasia and Nafisa. You can just stand up in the front. Great.
Thank you for giving us the opportunity to say a few words. We won't make this too long. I just wanted to say how proud I am of you, Dad, for how hard you worked over the past few years to be where you are now, and how wonderful today's presentation was. I know you barely slept last night, but all the hard work has paid off. Although I still don't know 100% what you do, I'm still in awe of the work that you do and how intelligent you are. Truly an academic weapon, and I'm so grateful to be inspired by you to pursue my own studies.
We've seen how nervous and stressed you've been the past few weeks preparing for this, and we want to say what an excellent presentation it has been. We've all learned, we all will be leaving this room learning something new, and you've always been a perfectionist, and this has been a perfect presentation, and your work has been at a very high standard throughout your whole career, and you've held us to that same high standard. And yeah, you can see the results of it. And thank you very much. We love you very much, and we're proud of everything you do and all that you've accomplished. And you'll always be our favorite person and our role model. Thank you very much.
Thank you, girls, Nasia and Nafisa. Their nicknames are Comet and Asteroid. Ladies and gentlemen, we're almost at the end of the formal part of this evening's proceedings. In a short while, I'll invite the congregation to stand, and the Vice-Chancellor, Professor Mtembu, Professor Swalaha, and the academic procession will then exit. And afterwards, we'll invite you to join us for some snacks. And all that's left for me to say is thank you for making the time to be with us this evening. Congratulations once again, Professor Feroz Mahomed Swalaha. Thank you to the Vice-Chancellor, to the Deputy Vice-Chancellor, the Executive Dean, the Deputy Dean, members of faculty, and everyone who helped make this a success. Thank you to Professor Swalaha's family for being here, for his daughters for saying a few words, I think encompassing that this is the DUT family. So from all of us, thank you so much. Good night and God bless. If I could please ask the congregation to stand as we prepare for the exit of the academic procession. Thank you. Thank you, everybody. Good night.